Hi, welcome to Maths. So previously we looked at a sampling method, simple random sampling, and this, in some sense, is the most random possible sampling method. We take the whole population, we either number them or we sort of write the names down in a hat. Of course, this could be for non-humans, so it could be like irons in a factory. So you wouldn't you'd write down every single iron you had, and then we pick them at random until we got the size of the sample we want. It's good because everything is equally likely to be picked. However, it could take a long time, could be expensive, could be time consuming, and it doesn't guarantee representation of all groups. So today, we're going to look at some other sampling methods. And actually, we're going to look at another 5 sampling methods, and there's more. Whilst researching this lesson a little bit, I found there's loads more I'd never heard of, so there's a lot going on. Okay, we're going to focus first of all on some other random sampling methods. They have randomness in them. There's going to be some that don't have randomness in them. The first one is called systematic sampling. So this is when you've still got your whole population, and you might be interested, not in, like you might want to do it a bit more quickly than doing a large simple random sample. So you could select, I don't know, every 10th person. That would be quite a quick way of dealing with it. So you'd probably first of all choose a number between 1 and 10. And let's say you get 2, then after this second person, you would pick every 10th person after. So 2, and then the 12th person, and the 22nd. So there's a slight element of simple random sampling in the very start, this number between 1 and 10. Not really, wouldn't really call it simple random sampling. And then it's every 10th. Of course, it doesn't have to be every 10. It depends on the size of your population. So if we look at an example, okay, and I'd like you to try this yourselves. I'm going to talk about it, but have a read. So a manager of a sports club basically wants to select 30 people from 120 members. How could they do a systematic sample of this size? Well, what they could do is they could divide the number of people by 30, and so they know they need to take every 4th person. It's just, do they take 1, 5, 9, and so on, or do they take 2, 6, 10, and so on? Well, that's where the random aspect comes in. Choose a number from 1 to 4, inclusive at random, and start with this member and choose every 4th member after that. After we've decided, the first sort of person, everyone else is kind of, there's less randomness going on. But I hope you can agree, there's still definitely a degree of randomness in there. Okay, next one, stratified sampling. Okay, stratified, this gets a little bit more complex, but it's as a result, it becomes a very good method. So stratified sampling accounts for the fact that you're going to get different types of people in your population, or again, I'm going to stick to humans, but it could be similar in other scenarios. So you might have men, women, and children, for example, and you might want to guarantee that you get the right proportions of these. Now, that would not be the case in simple random sampling. It could just be that you're unlucky and you pick like loads of children by accident. You say probability should get the right proportions, but it won't guarantee it. And then with a systematic, it won't be guaranteed either. This is the main focus of stratified sampling. We guarantee the right proportions. So if we look at an example, let's go back to our sports club, 120 members, 72 are male and 48 are female. How could the manager now guarantee a stratified sample for 30 of the members? There's one thing I've not quite said. Once we've decided how we're going to split it up, we then, to pick each person, do a simple random sample. There's still that involved. So if I say, right, these are the women in my population, I want 2 of them, To get the two of them, I would then either do random numbers, or a lottery search with their names. So that's where randomness still comes into it. Okay, this question, here's the answers. So what you do is you find the proportion of people who are male, 72 over 120, and you'd multiply that by the number that you want, and you're going to get 18 in this case. And then you can work out 30 minus 18, or do the proportion of females to get 12. Okay, so now you're guaranteeing that you're getting the right proportions of males and females. It's like not everyone's got the same chance of being picked now in some sense, but it's still there's still randomness going on. Okay, and then once you've got the number of males and females you want, you do a simple random sample. Okay, good. So we've done systematic and stratified. Okay, one more. This one doesn't start with S. Cluster sampling. Okay. Again, I'm not sure if it's more technical. It's just a bit different. So let's say you've got your population now, and you might consider a population, I don't know, of a little village or a town. You might consider all the different streets in the town, and we call these clusters. So what we then do is, instead of sampling people from different streets, we might just sample one street, one cluster, and we can tell ourselves, or we have to convince ourselves, or be sure that one street will represent the whole population. So rather than going around to lots of different streets, doing a simple random sample, or a systematic sample every 10th house maybe, or a stratified sample trying to get the right proportion of the population, I don't know, we can instead save a lot of time and just look at one street, Main Street in this case, and find out about the people on there, check every house, and then that will represent our whole population. So I've not really talked about advantages and disadvantages yet. I'm just talking about what these sampling methods are. You might start thinking, well, why would you want to do this? And you can see it's going to be quicker than going around lots of different streets. That's important in surveys. You want to get the good result, but you don't want to spend ages doing it. So here's an example. I actually made up this one. So Shropshire Council wants to test the reading level of 10-year-olds. Can you give a suitable cluster for which to include every student as best you can anyway? And how can you then use cluster sampling? Okay, my answer to this is, right, we can actually, I've made clusters here, and what are they made up of? Every school could be used as a cluster. Now, the reason I wrote almost, because not every student is in school. You might be homeschooled, you might not be in school. There could be different things, but you're going to get the majority. But yes, of course, there's going to be some issues with it. So you can consider every school to be a cluster, and then you can sample that by doing considering each cluster and using a simple random sample to select a sample of clusters to test. I don't think I said that before. So to get my streets, I might write all the streets down and then do a simple random sample. So in this one as well, we've got some simple random sampling. So it might be that I put all of these in some sort of big bag, hats, like hypothetically, or theoretically, and then I might say pick this one, and this one. In the Shropshire area, there's obviously more schools. You get a big enough sample to help you out. So those are 3 random sampling methods. I hope they make sense. You can see they work in slightly different ways, and it's not that one's better than the other. It's just that they have different advantages and disadvantages, along with simple random sampling, which I will be getting onto. Okay, onwards. So far, we've looked at 4 random sampling methods, and I just want you to pause for a moment and think about the names of those and what they are. I'm going to ask you, well, I'm not going to ask you, but I'm going to tell you in a minute. I want you to think about this. Okay, so the first one was simple random sampling. That was when you basically take names out of a hat. The second one we looked at was systematic sampling. That's when you take every 10th person, every 20th person, every 50th pair of shoes. To decide the first one, you've done a simple random sample. Then we've got stratified sampling. That's when you guarantee the right proportions in your sample. So you split it into strata. Could be people, could be different age groups. And then once you've got your little strata, you do a simple random sample within that. And finally, we looked at, I've forgotten, cluster sampling. See, very easy to forget. Cluster sampling, and then we split like a town into streets, which represented the whole population, or something, it's a similar sort of thing. And then you use simple random sampling to decide on a cluster or a few clusters, and you just look at those. Okay, they all take a fair bit of time, and that's why you might want to use a non-random sampling method, because it'll be a bit quicker. You won't have to do this, this kind of names in the hat sort of process. You might not know all, you might not know every single street or every single student or something like that. So these kind of take that into account. Okay, the first one is opportunity sampling, sometimes also known as convenience sampling. And in this case, I think it's like the simplest possible way of sampling. You simply choose individuals who are available at the time of study and fit the criteria you're looking for. So this is a bit of a tongue-in-cheek cartoon, but if you want to find out about the death penalty, you just shout out your window at people and you've got your sample, okay? Maybe not very good way of doing it, okay? But it's going to be quick. You're not going to need to know all the people in your population, so it does have some advantages, even though you need to be aware of the possible bias that can arise. Okay, so here's a little question for you. How could you make an opportunity sample of 20 shoppers in a city centre on a Monday morning? Well, this is what you could do. You could simply select the first 20 people and ask them. One thing is to fit some criteria is you might want to just ask the people who are carrying shopping bags, okay? Because although that won't guarantee they're shoppers, it will maybe avoid commuters, people just, people going to work, for example. So do be aware of that. You might have some criteria in there as well. Okay, and there's one more non-random sampling method we need to be aware of in A level, and that is quota sampling. I think this is one of the most complicated. I think I get a bit confused by this sometimes because I'm not sure the exact definitions, I've got to admit, and it might be different for different people, but I think I can give a good general overview. So quota sampling I want you to think about it like a combination of stratified and opportunity. So what you basically do is you split people into, I'm not sure if we call them strata anymore, but split people into different possible groups, maybe men, women, and children, or something like that. But this time, instead of doing a simple random sample to get the people, okay, I just basically use an opportunity sample. So this compares it quite nicely, I think. On the left, we split it into people with yellow heads, red heads, and blue heads, and then we've done a simple random sample to get our sample of 6 people. For quota, you just go straight to the nearest person with a yellow head, for example. And when I say there's a bit more to it, and it can be confusing, I think sort of an offshoot of this is that maybe within men, women, and children, you might look for some other characteristics. So you might say, right, I'm gonna ask, I don't know, 10 men, the first 10 men I see, except no, I'm gonna try and get a range of ages. So once I've asked, I don't know, a young guy, then right, I'm not going to ask any more young guys. I'm going to ask somebody that's middle-aged, and then I'm going to ask somebody who's a bit more elderly to try and get a better sample. So, the aspect that I'm saying about it being a combination of stratified and opportunity, I think the opportunity you could put some little dots under, and not always. Okay, you might try to get, because at the end of the day, you're trying to get a cross section of the society or the population, but in as easy as way as possible. Now, I don't know if when you go out shopping in a town centre or something, when you see people with clipboards doing surveys about certain things, now I reckon a lot of them are doing quota sampling because I think they've got like a certain type of cross-section of society they're trying to get, and then they wait for those people to walk by and then they ask them. I could be wrong. I don't work for a surveying company, but that's my suspicion. Okay, so how could I take a quota sample of including both men and women of 20 shoppers in a city centre on a Monday morning? Well, I think for this, the population is roughly 50%, 50%. I'm kind of, yes, okay, I'm saying people are either men or women here. Okay, fair enough. You can dispute some of the things I'm saying, but I'm just trying to give examples. What we could do is we could split the sample into 10 men and 10 women, and then we could select the first 10 men and the first 10 women. Maybe they're carrying a shopping bag. Maybe we do this other criteria as well. But you can see in this case, we're kind of guaranteeing a bit more of a proportion, not just the first 20 people that we see. Okay, we have covered how many? 4 random sampling methods and 2 non-random sampling methods. So you need to know the names of them. You need to know roughly how you would go about constructing sample sizes, especially for simple random sampling. That's the main one to focus on, I think. But be aware of stratified with the proportions. Just have a general awareness of all of them. Let's just go with that. Okay, so I'm going to test you on this now. Can you have a go at the following questions? So I'm going to talk about them, but pause the videos, try them first, and then see if you agree with me. Okay, the first one, we're finding an opportunity sample of size 5 from these hours of sunshine. Well, the easiest thing to do is maybe take the first 5 values. You could argue that, yeah, let's just take the last 5 values, or just the first 5 I see. I just happen to look at 20 first, I'm going to take those. But yeah, I'm happy with that, to be honest, as an answer. I'd say conventionally, you just take the first 5, and then we can work out the mean by adding them together, dividing by 5. Okay, next one. How about a systematic sample of size 5, starting with the 3rd day? So let's imagine I've kind of done a simple random sample to get to 3. And then I've told you that, and then I want my sample of size 5. What can we do? Well, we need to do it properly. Okay, to get the size 5, we can't just say, right, I'm going to take every the 3rd day, I'm going to take every 3. I need to get that value from somewhere. And what we can do is we can divide 30 by 5 to equal 6. I mean, in theory, we do that, and then we do this randomness to start at the 3rd day. This is like an exam question, so it's not exactly how you would do it. And then you would do the 3rd, the 9th, the 15th, the 21st, and the 27th. Brilliant. Okay, state with a reason which method is, oh sorry, I haven't done the mean yet. So the mean is going to be 5.4 after you've added them together. Which you think is more reliable? Okay, well, the systematic sample, because you're testing the whole month. With your opportunity sample, you're only testing the first 5 days. Hopefully you can see why that's going to be more reliable. Okay, onwards. So, bit of a wordy question here. We've got a factory manager, we've got workers with different ages. It's thought that different age groups will have different opinions. That's quite a key thing. Okay, have a go at this. I'm going to talk through it now. So, what sampling method should the manager use? Well, you can see that they definitely want to get these different ages in there, and the answer then is to use a stratified sample. How can we use this? Well, we've got 80 workers. We need to think about the percentages or the fractions of people. So there's 300 altogether, and then you can work out proportions. 75 over 300, that's the fraction of workers you want between 18 to 30, so 20 workers, and you can do the same for the other ones, just like we did before in the earlier example about the sports centre. If you get a fractional worker, then you're going to have to round it, and in this case, this one rounds down, and this one rounds up, so we're okay, we're not adding an extra person to it. Sometimes you might have to adjust it carefully, but that's all right, that's still going to be representative enough. Okay, and then Then we've got the right proportions, and you just need to then say, okay, you can't stop there. You need to say that you would then do a simple random sample. Maybe, depending on the marks in an exam, okay, if we just focus on exams for 1 sec, you should just explain how the simple random sample is working, so as they do here. Okay, brilliant. Right, let's look at some reads. Why not? So we're harvesting reads. How could we use cluster sampling to obtain a sample? Well, this is not really a numbers question. It's more about just understanding what cluster sampling is. So we can regard that we've got several read beds. That's quite vague, admittedly. But let's imagine we've got quite a few, but not ridiculous number. We can imagine them as clusters. We can select a few clusters, maybe only one cluster. It depends how many there are at random, and we can use a simple random sample to get this. Maybe all of them. Actually, to be fair, this is actually from an exam paper from a different exam board in the past that I found. So this was taken from the mark scheme. If you're wondering why the answer is as it is, because it was what the markers used to help decide giving the marks. Okay. Right, so that's it, really. If you understand that, then you've understood. I didn't ask about convenience, but I've covered, and I didn't ask about quota. They're a bit like tricky sometimes to pin down, so it's more likely you'll just get asked a bit about the advantages and disadvantages. But you could be asked roughly how you might comprise one, but don't stress about it. Okay, just learn the different types. Okay, the last thing we're going to look at is the advantages and the disadvantages. And if you're sort of in a classroom, you might say, well, write some of these down, discuss it with the people next to you. Let's try and come up with some ideas, because what I'm about to show you might not be the only good ideas coming out. They're just ones I've taken, found and taken. So I think arguing about it and discussing it actually gives a good feel for what's good about different ones. There's no like best method. They're all going to have kind of advantages and disadvantages. I'm going to talk through them now. So back to simple random sampling. I did already give some advantages and disadvantages, but here they are again. I'm not sure I agree. I suppose it depends what you mean by bias, because for me, with a simple random sample, you could accidentally just ask all of all the men and not any women or something. That could happen, and that feels like a biased sample, even though it's random. So I would probably change that to minimal bias. It's probably the best method for minimizing bias, but you could still argue, no, well, a stratified sample would guarantee the population. So let's say you do, it's not much bias. Let's say with that, you're at the lower end, okay? For small populations, it's great. You can implement it easily. However, if it's large, then it falls apart. You do need to know your sampling frame. That's like the people or whatever you're testing. You need to know everyone in there. So that can be a problem sometimes if you're doing it properly. Okay. Oh yeah, we've got the fact that there's an equal chance of selection as well. Systematic sampling. So this is going to be much simpler and quicker to use. And it can work for large samples and large populations. Technically, you still need to know everyone in the population. You need to know when to stop. So that's a disadvantage. And yeah, it can introduce bias if the sampling frame is not random. Okay, stratified sampling. So this tries to reflect the population structure. It's like that's the built-in mechanism. So it's going to guarantee proportional representation of groups within a population, which is not the case for the others. But you've got to take it, you've got to again know your whole sampling frame, you've got to know everyone, you've got to split them all into strata, and you still get the same kind of issues as simple random sampling. Okay. The last random sampling method, cluster sampling. Advantages, it's probably the quickest, at least out of the four we've done, the most time and cost efficient, because you're not looking at the whole sampling frame now. You might not even know it. You might just think, right, I don't need to know everyone on these streets, because I'm not going to select that one. Here are all the streets. I'm going to select this one, this one, this one. These are the people I need to look at. So it's going to be more time and cost efficient. However, how do you know that that street or whatever it is that you're looking at in your cluster, how do you know that represents the whole population? There could be pitfalls. You could, if you're looking at, I don't know, a town, you might happen to pick all the well-off areas or the less well-off areas or something, out of the randomness in there. So it does depend. So you've got to think about when it will be applicable and when it might not be. Okay, we're nearly there. Opportunity sampling is probably the easiest type of sampling to carry out. I can't think of a quicker one. Shouting out your window at someone to do a survey. Well, no, not ideal, but that kind of idea, going to a shopping centre, and it's going to be inexpensive. Not much has to be put in to do this. However, if it's rubbish, well, doing a rubbish survey isn't going to help you, is it? It's unlikely to provide a representative sample. So maybe you do it. I mean, we're only touching upon sampling methods really here, but maybe you just do it as a quick survey that doesn't take very long, and then you'd go into more depth. Okay, maybe you ask shoppers of their opinions of a new product, and you're just trying to get a feel for it, and maybe they give you some feedback. Oh, I don't like the label, or that advert was amazing, and then you can do more thorough market research. Okay, it's going to depend on the individual researcher if they're picking the first few people that they find. And also, one extra little thing that I've added is, if you're doing it at a shopping centre, for example, then you're going to miss out on people who don't go to shopping centres. Maybe they buy stuff online these days, or something else, or someone shops for them. You're going to miss out on their opinions. Okay, the last one, quota sampling. So again, we get the advantage that it's going to be much quicker than these random methods. We don't need the sampling frame. We can make comparisons. However, we're still going to get this issue of bias because it's non-random. It's going to be more biased than in those other random methods. We still have to think about dividing people into groups. It depends again on the method for how difficult that will be. If you're looking at, like if you said, as I said, maybe look at age groups within the gender type, that can complicate things. And then I suppose in all these cases really non-responses are not recorded as such, but when that's a different kind of issue within sampling, but it's probably most prevalent when you're going up to people and asking them what if they don't want to answer your question. But for me, that could still happen for any of the sampling methods. Okay, we're basically there. I just thought I'd show you, this is more for interest, but I stumbled across this page from the University of Hawaii, and they go into some other aspects of the sampling methods. They include the 6 we've covered here, and then they also talk about when to use it. So if you're sort of studying another subject, maybe, I don't know, psychology, I'm sure you talk about sampling there and other ones. And I think this could be quite an interesting read on when one might be better than another one. Anyway, that is it for sampling. I'm going to get you to practice this, learn the 6 methods. I'm not saying like memorize all the advantages and disadvantages, get a feel for it and know how to apply them, and then you'll be in a good place.